Okay, so more inheritance. And we're going to focus now on, in the examples we had, we focused on inheritance really of methods. I mean, we did some inheritance of variables too, but not in so much depth. And variable inheritance causes just more headaches. Okay? And we're going to wrestle with those in this section. Okay? And variables are something that you initialize in constructors, right? So constructors and variables go together, and we'll talk about both of them now. And I'm going to show you that collections are not the only examples where inheritance applies. We'll do a graphics example. Okay, we'll extend something we've already seen before, the point and Cartesian point example. And we'll look at inherited variables, and we'll look at constructors. Okay? And of course, variables and memory representation go together. So we'll also see how an object of an inherited class is stored in memory compared to an object of the superclass. So let's go back to something we've seen before, our point interface. Remember, this was the interface that had both Cartesian coordinates and polar coordinates. So we had, and this is something you guys have used in your project, so that you probably know this very well. And so again, our point, as it turns out, did not have any setters. So it was an immutable object. And every time you wanted to change your location, you had to create a new instance of this particular class. And this is where things become interesting from the topic at hand. We had an implementation of this point, which was a Cartesian point. It stored the point as in Cartesian variables, x and y, rather than polar. And it took a constructor that took both the Cartesian coordinates and the polar coordinates. And in the case of the polar coordinates, it did some mathematical magic to convert the polar coordinates to the Cartesian coordinates. Okay, so we had two constructors. So now I got an example with variables and constructors, which is what I need to drive home what happens with these concepts. Okay, so nothing else interesting other than the fact that we have two constructors and we do not have a null constructor. Okay, that's also going to be important. Okay, questions so far? Okay. So what we're going to do is make more fancy points. Okay, so our point did not allow have setters, so we're going to have setters for the Cartesian coordinates. Okay, so we'll say set x and set y. We won't have set angle and set radius. That just makes the example more complicated without illustrating new concepts. So I've got now a set x and a set y, a mutable point. Okay, I'm going to now have an extension. That was the interface. Now we have the class, and in the class I define a mutable point which extends a Cartesian point and implements mutable point. Okay, that's like a string database extends a string history, implements string database. Okay, I've extended the interface, I've extended the class, and my extended class implements the extended interface. Okay, nothing new so far. But you do see something here that we didn't see before. And what's that? The super call. Okay, so I have a constructor which takes the x and y coordinates, and I go and do super the x and the y. So what is this super doing?
It uses the same code as the super constructor, but you can realize that the constructors will have different.
So it's using the super constructor. That's what you're saying, right? So it's basically calling the super constructor. Just as an add element, I had a super.add element, if you guys remember. I overrode, and when I overrode, I reused. Okay, I said super.add element. So there I had to say super.method name. Here I don't say super.method name because the constructor is implied. So I'm calling the superclass's constructor. Remember the constructor, the superclass had two constructors, one that took Cartesian coordinates, one that took polar coordinates, and which one am I calling? These are two integers, so I'm calling obviously the Cartesian one. Okay? And is that something I should be doing? I'm illustrating super, but is that something I should be doing to make this class work? I need to initialize those variables. Okay, so I do really need to call them. Okay, so that's what this magical super is doing. So, you guys understand Yeah.
Is it that programmed to extend a class just to use the same code and only alter if you didn't add the set X or set Y, because for my token classes I just extended one, but I didn't add any extra.
Okay, so that's a different question. Can a class extend another class and not add any code after that? What do you guys think? He said he wants to do it for his token class. Anybody else want to do that for your token classes? Yeah, you all want because they're different tokens. It's okay. It's saying that, look, and it's also saying later I might add some methods. So you're saying, look, I've got a special case, and the only thing that's different from this is that its name is different. And I want that name to be different because I want to distinguish between a numeric token and a command token. They both happen to have maybe only one property. Okay, so they'll access that. So that's fine to have empty classes that just extend. It's perfectly fine. Yeah, Marco?
So if you didn't have, we know that Java automatically creates a constructor, right? You don't have.
So if I did not have this at all.
Yeah, let's say that you remove everything that's inside that immutable point class.
Yeah.
Would it be able to construct the object based on its parent?
Okay. So if I had nothing in here, would that be legal? Okay. And let's just defer that question for a little while. Okay. As it turns out, the answer is no. Okay. And let's just understand this a little bit. And I guess I'm going to answer it right away, in fact. So, would you say that the superclasses constructors inherited? Yeah? Would somebody say it's not inherited? You know, the TS put a quiz question. Are constructors inherited? And they thought the answer was no, at least one of the TAs, and I thought the answer was yes. That means there's some confusion here. So it's inherited because, yeah.
It's a little different because you can have multiple ancestors, and super really called the first parent. So like
Okay.
classic in two classes before this one.
Okay, so since you can have a parent and a grandparent and a great-grandparent, the question becomes which one is called. But in general, the most immediate parents' methods are called. So we could have a rule that says, you know, it's the parent class. But I think you're getting to the more fundamental point I'm getting at is that parent's constructor really inherited? Those of you who think it's inherited because? Because it's a child, and I can, and yeah.
And constructors are method and inherited methods are members.
So you're saying by that logic, a constructor is a method, methods are inherited, so this must be inherited, right? But there's a little difference here. If I don't override a method in my superclass, if I don't override add element in a string set, that added element is available, right, to my instances. I can override it and call super. That's fine. If I don't go and say super explicitly, that constructor is not available to the users of my class. That's a big difference. And that causes all kinds of confusions. Okay? So, if I don't call this super, if I don't define this constructor with the x and the y, then that parent constructor is not even available. So in this particular class, remember in Cartesian point, I had two constructors, one that took polar coordinates, one that took Cartesian coordinates. The constructor with the polar coordinates is no longer visible to instances when instantiating a mutable point. We've just hidden it. Even though it's inherited, it's available for us to call, it's not automatically available, and we'll have to go and define another constructor that takes those two parameters and says super, and then it becomes visible. So it's visible, it's callable, maybe that means it's inheritable, but it's explicitly inherited and not implicitly inherited. Okay? So that's an important point. So this is a superclass constructor that I'm calling, and it's inherited but not available to users of the class if not called from subclass. So that's a very important point in it. Okay? Questions? Okay. And let's start now doing lots of different things. before we go to that, let's make things even more interesting. I'm going to create a bounded point that extends a mutable point, and it just bounds the point to be within some rectangular area. Okay, you cannot move that point away from that area. We'll just call that a bounded point. Okay, and that rectangular area will be defined by an upper left corner and a lower right corner. Okay, just as that's a valid way of defining a rectangle. Okay, so now I'm going to have a set. We're going to allow those points, those corners to be changed. So we're going to go and have setters for that and getters for that. Okay. Again, why such a class is important is not that relevant as the fact that I've added some more properties here. Okay, and so now I have a grandchild class also. I've got a bounded. Did I call that a bounded mutable point, or did I call it a bounded point? Okay, I hope I don't have some inconsistency, but it's a bounded mutable point, and I think I've messed up a little bit here. So this should be bounded point, and this should implements bounded point. Okay, so I'll correct that later. But I go and define these two variables to have the two corners, and now I have a constructor that takes 4 parameters. Okay, 2 of these parameters are parameters that are relevant to initialize my not parent class but my grandparent class. Okay, and 2 of these parameters initialize my own variables. Okay, so what I did was I said super init x init y. Hey, parent class, pass it to your parent class. Okay, and finally this value will be used to initialize my Cartesian point. And then I go and initialize these 2 variables. And the x and y that I got may not lie in the rectangular area that they're supposed to lie in. And if a point is outside that area, I'll just force it to be at some corner of that area. Okay, I'm not even sure that I've got these functions right or not. But the point is that I have to fix the location of x and y in case they are not at an appropriate location. So I've defined this fix x and fix y to do that. Okay. So, any questions about what's happening in this constructor? You need to do things like this a lot. Okay, where you have a class, you define additional variables, those have to be initialized by your constructor, and the inherited variables are initialized by the constructors of your superclasses. Okay, and you have to call those constructors, otherwise they're not called automatically, and then you have to go and initialize the other things. Okay, so any questions so far? Yeah, Frank?
So the super constructor here allows the superclasses to use those?
No, what am I doing? I'm making a call that says super.constructor. .constructor doesn't have to be said. And I'm saying, hey, parent class, take these x and y and do what you do in your constructor with it. Okay? What does it do? It says, I don't do anything. That's my Cartesian point. That's my mutable point. I'll go and pass those 2 same parameters to my parent class and say, you do what you do with those 2 things. And what does Cartesian point do? It uses those variables, which are init x and init y, to give initial values to the x and y variables. That were defined in which class? A Cartesian point. Okay? And I'm just making through this super. Yeah. This super calls the constructor in the parent class and not the grandparent class, but the parent class calls the constructor in the grandparent class. Yeah, in that case, when we had a string database, we had a string set which was extending a string database, which was extending a string history. A string database never had an add element. So when you said super dot something, it went up the superclass chain to the first method that was available. In the case of constructors, it's always the immediate parent because these are not automatically inherited. So it's always the immediate parent which has to dispatch it to its parent. So this has to be manually done. Okay?
As far as memory management, are variables being stored in the grandparent class or are they being stored inside the actual?
Okay. So the variables being stored in the grandparent class or the parent class or in the immediate class. These are instance variables. These are not class variables. Instance variables are stored in the class or the instance of the class. Okay? So they're actually stored in the instance of the class, and we're going to look at memory representation pretty soon. But the answer is neither of what you said, none of what you said. They're stored actually in the instance. And the instance has all of those variables. Okay? Ashley?
And what is our parent class for this?
It's a mutable point. Yeah, I've got a little figure afterwards to make it, yeah. It was, remember, we started with Cartesian point.
Right.
It did not allow x and y to be changed. We went to a mutable point, it allows x and y to be changed. Now we go to the bounded point, which allows x and y to be changed, and the area, and when you change them, they remain in some rectangular area. Okay, so I defined 3 levels. And I think I've got my names a little messed up. Okay, I never used these things in any real application. I just created this example for this, and I think I did some PowerPoint editing rather than, actually I've got this on Eclipse, but something went wrong. Okay? Okay, and this fix x and fix y are called from the constructor, and so this is a superclass constructor. And what's interesting here is that unlike in previous examples, I've added new variables to my subclass. And that's why the question becomes, where are they stored? Okay? And in string history and string database, and string set, we did not add new variables. We got all our variables from string history. We just went and changed the methods. Now we've complicated things by adding new variables, and then the question becomes, where are they stored? And that's, and we'll answer that question. Okay? Other things? Okay. And my fix x and fix y are being called everywhere that x and y can change. Okay? Or the boundary points can change. So just like in your avatar, you have to make sure that it's always consistent. If you go and change the position, if you go and move it from anywhere, the avatar should remain connected. So it's the same kind of thing, and it's not that important. Okay? So I think my animation is gone a little wrong here. So let's just, okay. So now we are seeing a little bit better what happened. My x and y got defined in a Cartesian point. My mutable point just allowed those to be changed, didn't define new variables. And my bounded point went and added two new variables, lower right corner and upper right corner. I'm not showing you the methods because we understand method inheritance. I'm focusing on the variables here. Okay? So this is our picture to illustrate what's going on. Okay? So far, things clear? Okay, now let's start having fun. So in my constructor, I said super init x init y, right? And we all decided that was a good idea, or at least you guys didn't object to me doing this. Now let me go and make the super call at the end of the method rather than at the beginning. Now when we did our add element, remember, we said we did not do super right at the beginning of add element. We said if member, if not member, then super, right? So similarly, should I be able to just move that super here? So there are 2 questions. Is this program correct after that? And secondly, should Java allow you to do this? So is it correct?
It's not correct, but Java will allow you to do it.
Okay. So let's explain to me why it's not correct.
Because you're fixing x and y, and then you're setting it through the super constructor.
Okay.
Therefore, you can set it outside your box. And it won't catch.
So I'm fixing x and y, and then I'm going and setting x and y, so I'm not fixing the x and y I inherited. Okay? The program is correct. Now the second question is, will Java allow it? Kristen?
I'm curious, would x and y be set as null, or are they be initialized in the previous parent?
No, if Java allowed us to do this, okay, then x and y would be initialized to init x and init y. After we have gone and done, when fix x and fix y were working on it, x and y was 0. Okay. If you don't initialize anything, it's 0. James? Sorry?
X and Y don't have a type declared.
X and Y don't have a type. They do, right? In Cartesian point, I declared them to be int. So assuming it compiles. So, okay. Anybody want to say that because Yeah.
Your superconstructor call has to be the first call in your constructor.
Okay, so you're saying Java will not allow this because the super call should be the very first call in a constructor. Okay? And, if Java had that rule, our bug would be found, right? So for this particular example, that's a very good rule to have because it's better Java catches a problem rather than some smart student catches a problem, right? So what would be the rationale for Java to have that rule? I know in this example it works. So we can just say, to make our example work, we can change the language. Or we can say, look, there's something fundamentally wrong that's happening if I go and do super later. Which is what? Basically, you're right.
X and Y are fixed within the bounds because they're set by the constructor after you call to fix on them.
Okay. So in this example, exactly what was said earlier, that, you're fixing them later. You're fixing them earlier than they should be fixed. Okay. I agree with you, this example won't work. But what rule could Java use in general, without looking at this example? Some very abstract rule that says, you know what, if you don't do super at the very first statement, you're doing something wrong. Not only in this example, but any other example also. Yeah.
Is it like the order of operations?
It's the order of operations, okay, good. And it's the order of initializations, because the operations are initializing. So it's the order of initializations. So if I was saying the super call should be the very first call, I'm saying that my super class variables should be initialized before my subclass variables. Does that make sense? Yeah, James?
Yes, because theoretically, subclass variables require subclass variables.
Theoretically, my subclass variables could depend on my superclass variables. And my superclass variables are visible in the subclass. So that can happen. Or they can be visible. My subclass variables will never be visible in the superclass because the superclass doesn't even know my subclass exists. So if you're going to have an order of initialization, you might as well have the superclass variables initialized first and then the subclass variables initialized. So Java indeed has a rule that says that the super should be the very first call. And if you're not doing that, you're doing something wrong. And that's a very fortunate rule to have because that will catch my error that I made. Okay? So this is not allowed. Super call must be first statement in constructor, but not other methods. Not in my add element. Because by now the variables have been initialized. So not an issue. It's only an issue when the variables are being initialized. Okay? So subclass may want to override initialization in superclass, which is exactly what we want here. We want the fix to be done later. Okay? And subclass variables initialized before superclass variables initialized before subclass variables, which can use the former. Did I say it wrong? I think I got the former part wrong. Subclass variables can use the superclass variables, basically. Okay? Okay. Questions? Okay. And subclass variables are not visible in superclass, just as I said. Okay. Now we'll answer the question that Marco posed. What if I don't do any super call and I say, you know what, I don't want to learn new Java. I don't mind typing extra. Okay? So I will go and initialize, actually I didn't do that here. That's my next example. Okay, so I don't put a super call here. What should Java do? So I have not initialized the superclass variable, something wrong. And so this is wrong. Okay? And Java will complain there is no supercall here. Okay? And why is it doing that? The general rule is, again what we said, the subclass variables can depend on the superclass variables and you haven't even initialized them. Okay, so maybe not initializing them is as bad as initializing them late. So again, it'll complain. Okay? So want superclass variables to be initialized. Okay, now this is the example I was going to. Is that a good rule? Given that I could have initialized the variables myself. Okay, so I could have initialized x here and y here, and then that rule of Java seems all draconian. It's forcing me to understand this new call, complicated call super, when I could have initialized it myself. And yet Java says, no, even if you've written this program, there's something wrong. James?
Because other methods for super can't see your x.
A little louder.
Other methods for super can't see your x and y.
See the visibility of x and y, other methods other than super cannot see x and y is what you're saying, but x and y are visible everywhere. The question is, are they initialized or not? We are obsessed with initialization right now. That's all we care about. Okay? And I have initialized them. I've written, I had to go and type 2 lines here. That's fine. I don't want to learn about super. So Java could say, okay, I won't have that rule. I'll let you go and initialize it yourself, and I won't force you to understand yet another construct, because, the heavier the language becomes, the more you have to learn, and it just becomes, the threshold to using it becomes higher. Okay? So, could something go wrong if I did not have a super call here, given this particular program, this specific program where I'm initializing superclass variables? Could something go wrong that Java doesn't want to go wrong? Yeah. Okay. Yeah.
Could the superconstructor somehow manipulate the x and y before it actually sets into x and y? When it's doing this, you skip over that process and then somehow then do it out with the.
So you're saying the super method could have done certain things that you're not doing. And so you may not be correct. Indeed, we saw that previously. I was not initializing. So that could be one reason. But let's say you're a really good programmer. You just don't want to learn programming languages. Okay? So you don't want to learn super, but you will never write a bad program, yourself. Could you still get into trouble no matter how smart and good you are? Marco?
What if you extend this class?
What if I extend this class? That's okay. My extended class calls this constructor, and that constructor does its job. The key is that there is another class that we are not talking about, that we didn't write, that is in this whole picture. So our picture is that our bounded point is an extension of a mutable point, which is an extension of a Cartesian point, which is an extension of object. Do we know what's happening in object? It might have some stuff that has to be initialized. You can do everything you want to, and look at all your superclass chain and say, okay, I have subsumed the functionality here. But unless you rewrite object's constructor, you are not going to be able to do the right thing. And if you start rewriting its constructor, all kinds of bad things may happen that the programming language designer assumed won't happen. Okay? So Java really wants object superclass constructor to be called. So it says, no matter what you do, I want you to forward this constructor to your superclass, and I want it to forward it to its superclass, and so forth till I get the supercall. I meaning object.
So when you create a class that doesn't extend anything visibly, it extends object, and then Java just puts in an invisible super.
Okay, so that's a very good question, and I think I'm answering it right in the next slide. Okay, so let me just. So this is not right, because Java complains that no supercall, wants object variables to be initialized. And then the big question becomes, when we did so in this case, okay, so I'm going to get to your question in 2 stages, okay? First, I have a string set that extends string database, and Java allows this to happen. I can define a null constructor string set and not call super, and Java says fine. And if it's saying fine, it must mean what? It wants the superclass, the constructor in the object to be defined. So if you don't put a super call, it will do what you think? And you kind of answer that question. Java will automatically go and put a call to super. Okay? And do any of these things? What does it do? it automatically puts this constructor with this particular super in it. So that's what's happening when you don't explicitly say or implicitly say object. When you don't put any constructor, you're saying call that particular one. Okay, and that's convenient because typing super is a pain. And when I give you those simple examples before, I don't even have to mention super. So if you want to use Java in a certain limited way, I don't have to go and expose you to this super call. Okay? So it puts it in the object code. I mean, it's not as if your source code will change. Okay, when it compiles it, in the compiled code, you can go and put this. By the way, that's something you can do. I can take your classes that you've compiled, and at runtime, I can add new methods to it, and Java has a great facility to do that. So if I want to grade your assignments, I can take your classes, add some calls before each method, trace in what order the methods are occurring, and really go and get an idea of what's happening dynamically in your program. Okay, that's this. Do that even as a user. Okay? So let's go back to this particular thing. When I did not put a super call, Java was really trying to go and, it basically didn't like it. It couldn't, okay, so it couldn't put a super call here because, so why, okay, so let's answer that question a little properly. So what about here? Could it have put a call to super in this particular class, in this particular constructor, by our rules? There is no super call, so could it have just said super with no parameters? No, because there is no null constructor. Okay? If there was a null constructor, it would have put a super call like that. Okay? Okay, if Java is being so smart, it's adding super calls when they don't exist, and it's adding constructors when they don't exist, why can't it put a super call to a Cartesian point and give some parameter values to it? Why can't it call my parameterized constructor also automatically? Lynn? So you're saying it has more, maybe the constructor has more parameters? Maybe you didn't receive those parameters here? In any case, it may not know the relationship between these parameters and those parameters. That's in your head. James?
But the symbol doesn't it automatically, even if you put a full constructor, not an open constructor, it automatically calls objects constructor?
It calls super. It automatically calls object constructor, not directly, right? If I'm in a grandchild class, it's just calling my parent super constructor, which will call super and so on. Ultimately, things will go to object, one way or the other. You can't avoid that. That's what Java's ensuring. That's its basic principle. All these rules are trying to avoid. But basically, we don't know the parameter values will be, how many there will be. I could have a rule, so does not know what the actual parameters should be. We could go and put zeros for the parameter values. I could do that. I mean, that wouldn't be such a bad idea. Except that I have two constructors there. I have the constructor for Cartesian, with Cartesian coordinates. I have constructor with polar coordinates. Which one should it call with zeros? Okay? So it becomes very, very confusing. And so there may be multiple constructors. Which should it choose? So it will force you to go and put this. Okay? So when you guys do subclass, Java is going to have all these messages. I want a constructor. And this is what it's doing. Okay? By the way, even though Java will not do all these smart things, Eclipse will try to do smart things. You can tell Eclipse, hey, given that these variables are 2 ints, and given that my superclass constructor takes 2 ints, why don't you generate a call for me? And it will do that. Okay? It may not be correct, but it'll try to do something which you can rectify. But as a language, it won't do anything. This won't happen.
When you're at the top superclass, does it just have an implicit superclass object?
So yes, ultimately, that super of the object should be called directly or indirectly. So in Cartesian point, I had a constructor with 2 parameters, remember? There was no super call, which meant a super call had just been inserted automatically. Questions? I told you, inheritance is complicated. Okay, let's look at, now we'll answer Christian's question. Okay, what is the memory representation like? So, if in the quiz you get a question and say, how big is the memory of a Cartesian point, and ignore any variables declared in object. Actually, there are no real variables there, but you still need to do some initialization that you can see. How many words of memory does an instance of a Cartesian point have? Each int is a word. How many slots are there? So there'll be 2 words. How many words of memory does a mutable point have? 2. How many words of memory does a bounded point have? 4, 6. Things become complicated. It has at least as much it occupies at least as much memory as its superclass instances do. Plus it has 2 more words which happen to be pointers or actual values. Pointers. So if they're pointers, the answer is 4 or 6? 4. Okay, if they're pointers, if they're not copied, it's just 4. Okay, so let's slow motion. I have a Cartesian point, I have a bounded point, and I say new bounded point 75, 75. Okay, those are the first two parameters of the constructor. And then I have new Cartesian point 50, 50. That's fine. New Cartesian point 100, 100. I think my example is, again, I don't remember whether my parameters were Cartesian or mutable. So I might again have a little issue here that these might have to be mutable points. But either way, the memory is about the same. It's exactly the same. So we have a new bounded point 75, 75, which takes the x and y coordinates, the upper left corner, the lower right corner. The upper left corner and the lower right corner, right? And when I evaluate this expression, is the new on a bounded point going to be done first, or a new on a Cartesian point? Which one of these 3 news will be done first? What do you guys think? So I have this long expression, and I'm going new bounded point 75, 75, new. Which new will be processed first? Bounded point? This Cartesian point, or this Cartesian, the first Cartesian point, second Cartesian point? Okay. Why should bounded point not be done first? To construct the bounded point, I need a Cartesian point. I need the upper left corner before I have the bounded point. Before I can call the constructor of a bounded point, I need the Cartesian point. Right? And then the question becomes, this one first or this one first, and then, computer reads like English readers left to right. When you guys did your tokens, you created tokens left to right. So it just goes left to right, and it does first this Cartesian point, and that's going to allocate some memory. And because, I got this, 50, 50. It puts 50 here and 50 here, and this 8 underscore happens to be what? The location of this 50 or this 50? The first 50 or the second 50? First 50. Okay, the first slot's address is the address of that whole block. And it will allocate both these values in successive locations. Okay, so that it can find those values easily. Okay, you don't have to have a pointer to each field. You can just have a pointer to the first field, and then we can go off that through offsets. Okay, you guys will study more of this stuff when you study assembly language. Okay, and then it does the other Cartesian point, and now I've got 100 and 100, and I've got a location called let's say that's 16. Okay, and now I'm going to have my bounded point, and it's got those 4 slots, and I've got 75 here. I've got 75 here. Those are my 2 int values. And I have the address of the first point and the address of the second point. Okay? And this is done each time you instantiate a bounded point. You'll get 4 new slots. It's not as if these 4 slots are there for all instances. That's why your one avatar can be at a different location from another avatar. That's why one angle can be your arms and one angle can be your legs, because they happen to have different state. Okay?
Is it illegal to create a null constructor when you're using inheritance in subclass?
Is it illegal to have a null constructor when using inheritance? If you noticed in my string database and string history and string set, I had null constructors.
Well, if the subclass is super use parameters.
Okay, what do you guys think? The superclass has a non-null constructor. Can a subclass have a null constructor? Yes. And that would be useful because you could set default values. So supposing you have an image class, that's a generic image, and now I have image of Arthur's head. Okay, my superclass can take a file name as an argument. My Arthur's head can go and put the image for the Arthur icon and pass it to the superclass. So I'm fixing certain values that are variable in my superclass. My superclass is parameterized. My subclass is saying, I don't need all that freedom. I'm going to just fix the image for you. Okay, I saw another hand go up. Yeah.
Just making sure, like, your set variable thing would have to be class variable, so we still call it super first, right?
Sorry, you're saying two things. You're saying those variables will be class variables. You don't want class variables. You mean static variables or
Well,
instance? You mean instance variables?
the instance variables, yes.
Okay, they'll be instance variables, and they still will exist, and you have initialized them.
And what's called, it's still called constructor first, if you have to, right? Even though it's no constructor, sorry, you'd have to call it super constructor first, and then no constructor.
In the null constructor, you'll have to call the superconstructor in the very first statement. Absolutely. I'll show you an example later. And that example, I'll try to make 2 points. You can do it. And the second point will be you shouldn't do it in that particular example. I'll talk of the do's and don'ts of programming. So I'll show that the vertical line could be a subclass of a line, where the vertical line just constrains the line to be vertical. And we'll see that we can go and pass fewer values to the constructor. And then I'll say, that's probably not a good idea to do anyway. Okay? But in this example where I'm saying, look, this is the head of Arthur, this is the head of Lancelot, that could be a subclass of some image class. In fact, that's probably a good idea to do in your project. Okay? Questions? Okay, let's confuse you. Okay, so basically, just to make this clear, this x and y correspond to, these two slots correspond to inherited variables, and the other two slots correspond. I got my arrows a little wrong, sorry. But these two slots correspond to, I did a lot of editing yesterday, and I guess I haven't got it consistent. These two slots correspond to these two variables, notwithstanding what these arrows are saying. Now let me confuse you. And this is really confusing. So we want to have fun with Java, right? So I have inherited variables x and y, and I have created in my bounded point x and y. Will Java allow this? And if it does, what are the semantics? Yeah. So do these variables override the two variables? And what does override mean? Replace them? Does my memory still remain 4 variables? And these x and y replace those two variables? Is that your interpretation? I think that's what you're saying, right? That would be a very good interpretation, actually. Any other interpretation? That's not what happens, actually. Yeah.
Would it be 6 then, and you have 2 sets of the x and y?
You have 6 and 2 sets of x and y. You like it? I don't know what Gosling was thinking when he did this. In Java would not, Smalltalk wouldn't allow this. And Java allows it. And the reason you see a little frustration in my voice is because I have got burnt by this so many times. What happens? I have a subclass, I have a class, and I decide, you know what, I should really create a superclass also. So I start copying and pasting code to my superclass. And I forget to go and delete my x and y from this. And I do put x and y in my superclass, but I forget to delete x and y from this. And what happens is that you have duplicate variables, and these duplicate variables are accessed by subclass methods, and the inherited variables are being accessed by my superclass. So my superclass constructor is initializing those variables, my subclass constructor is accessing these variables, and I don't know why my program is not working. Okay? And I'm not the only one who does this. There are tools to go and find this problem. There are tools to go and do check style, which will catch you and highlight and say you duplicated these variables. Eclipse will give you a facility to go and move these variables automatically. And like I said, Smalltalk didn't allow it, and Gosling made a deliberate decision here, and he must be thinking of some examples which I don't have imagination to think of. But I know as a mere mortal, I have got burnt by this. Okay? And so, and you guys will too, so just watch out. I'm not explaining this just to give you the boundary conditions. This will happen. When you guys go and replace your token classes with a superclass, you'll want to move your input string variable to the superclass, and you may forget to go and cut it, and you may only paste it. Okay, so beware. Okay? Questions? Okay, so Smalltalk did not allow redeclaration, and this accidental redeclaration can happen, so watch out. Okay?